if I give you this problem, f of x equals 2x plus 3. Sometimes instead of f of x, you'll see me write y equals 2x plus 3. Now, x here is my independent variable. And y is my dependent variable. Why we call it dependent? Because the value of y will depend on what? On the value of x. That's why it's called a dependent variable. Just some terminology. The domain. The domain is what? What can we use for x, values for x? So the domain is really the x values. And the range is what? Is the y values. So in this example, y equals 2x plus 3, what is my domain? What's the domain? All real numbers, right? Any value for x that you pick, you will have an answer to it. And the range is, what are the y values? Going from where to where? From where? Yep, correct. All real numbers, right? Not just positive. So if you want to write that as an interval notation, we go, the domain is from negative infinity all the way to infinity, from 2. And the range from negative infinity to infinity, all the numbers between negative infinity and infinity. Again, the reason for that, if you graphed it, this is what the graph will look like. When x is 0, what's the y value? 3, right? And when x is 1, what is the y value? Is it a 5? So when you graph it, notice it keeps going, it doesn't stop. So you can see the x values goes from this end to that end, all the way, there's no exception. And the y value goes from where to where? From here all the way to here. So from negative infinity also to positive infinity. Is it always going to be this case? The answer is no. Let's take this one. Y equals x squared plus 4. What's my domain? What's my range? Domain from negative infinity to infinity, okay, which means all real numbers. What about the range? Well, we might have to graph this to see what it looks like. If you graph this one, when x is 0, what is the y value? 4. When x is 1, what's the y value? 5. We know this is a parabola, it's going to look like this. So what is my range? Does it equal to 4? Can't be all real numbers. Greater than or equal to 4, right? So how would you write that? You can say y is greater than or equal to 4. Or an interval notation, that's from where to where? From 4 all the way to what? Infinity. Notice how I wrote that. Square bracket at 4, parentheses at infinity. You ever seen that notation? Square bracket means what? The 4 is included. Infinity will never be included because we can't reach it. So when you type that on WebAssign, you're probably going to see these brackets in red to let you know they're not matching. That's okay. So my range is from 4 all the way to infinity. Is the domain always from negative infinity to infinity, or real numbers? No. I'll give you a simple one, 1 over x. My domain. What's the domain? Is there a value or values that we can't use for x? 0. X cannot be 0. Because when x is 0, what happens? You're dividing by 0. So your domain then from negative infinity to where? To 0. The u from 0 to infinity. What's u here? What is that? Union in set notation. The union means or. So from here to there, or from 0 to infinity. That's your domain. All the numbers but 0. My range, again, I gotta look and see what the graph looks like. If I was to graph that, it can't be 0. So let's take some values for x and see what the y value is. I can't use the 0. This is undefined, which means you will not have a value when x is 0. But let's try like 0.1. When x is 0.1, what's 1 over 0.1? 10. When x is 1, what's 1 over 1? 1. When x is 1,000, what is 1 over 1,000? 0.001. So if I was to graph this, this is what the graph will look like. This is the 1, and way down there is 1,000. There's 1,000 right here. And there's the 0.1 right here. So at the 0.1, what was the y value? 10. At 1, it was 1. At 1,000, it was what? 0.001. So the graph looks something like this. Where are you? Like this. And what about when x is a negative value? How about a negative 0.1? Negative 10. What about a negative 1? Negative 1. So I can see the graph looking also like this on this end. So what is my range? Notice we have y values all the way across. See, and we have values for every one of these. We have values for every one of these. The only one we don't have a value for is where? 0. Y does not equal to 0. Can't be 0 because you will never reach it. You'll be close to it, but you'll never touch it. So my domain now, or my range, is going to be from negative infinity to 0. Neither one is included. Add to it from 0 to infinity. So when we ask you for the domain, you really, two places to pay attention to is, do you have fractions? If you have fractions, find out what value or values will make the denominator of the fraction 0. And whatever value there, you can't use it. The other place is when you have a square root. You know you can't take the square root of what? Negative number. So if I said to you, can you tell me what the domain for y equals the square root of x minus 4? The domain again, you want to make sure x minus 4 is what? Greater than or equal to what? 0. It has to be. You can't take the square root of a negative number. Can I solve this? X is greater than or equal to what? 4. That's my domain. By the way, another way to write the answer, you can write parentheses, that's set notation, x such that line means such that x is greater than or equal to 4. X such that, that's what that means. X such that, that's the line up and down, x is greater than, all right, I should write is greater than or equal to 4. Well, everyone knows greater than or equal to 4, so I'll just put greater than or equal to 4. But that's what that line means, such that. X such that x is greater than or equal to 4. Or you can say from 4 all the way to infinity in interval notation. That's called interval notation. In case you never heard these terminology. Now, if you were to graph that, again, we tell you can't use any value of x less than 4. So you can begin with the 4, try the 5, try the 6, try the 7, try the 8, if you want to pick a lot of points. When x is 4, what is 4 minus 4? 0. The square root of 0? 0. When x is 5, what's 5 minus 4? 1. What's the square root of 1? 1. When x is 6, what is 6 minus 4? What's the square root of 2? When x is 7, what is 7 minus 4? 3. The square root of 3? 1.72. When x is 8, 1732 if you want to actually. 8 minus 4. 4. Square root of 4? 2. So when you graph that, the graph will look like this. 4 and 0, 5 and 1. So it will look something like this. Keeps rising. So what is the range? What is the y value? From where to where? Y such that y is what? What is the smallest y value that you see there? 0, and it goes all the way to where? Infinity. Starts at 0 and it goes higher. So my answer for the range from 0 all the way to infinity, including the 0, not including infinity. Let me modify that problem just a hair. Let's say I took the same problem, but instead of give me the domain and the range, I go y equals 1 over the square root of x minus 4. How is that different than this one, the one above it? It can't be 0, correct. Because when x minus 4 is 0, there is a square root of 0, but 1 over 0 doesn't exist. So in this case, you want to make sure x minus 4 is what? It's greater than 0, can't equal to 0. This one can be 0, that can't be. Because you'll be dividing by 0, and that's a no-no. That means x is what? Greater than 4. So your domain, x such that x is greater than 4, or an interval notation that's from 4 to infinity. That's the domain. What's the range? Well, we just graphed it there. So if you graph that again, this is the 4. So it's an open circle there. And it looks like this. Same as before, except you can't use the 4. You can use 4.1, you can use 4.01, 4.2, 4.3. So what is your range? Y such that y is what? Greater than 0. So that's from 0 to infinity. One more example on the domain, the range, then I'll leave it alone. I think you got it. Find the domain and the range of y equals 3 over x squared minus 4. Begin with the domain. Can we find the values that will make the bottom 0? Keep going. You only gave me 1. You get half a point. Plus or minus 2, because you take the bottom and you set it equal to 0. You can factor that if you want to. Set each factor equal to 0 and solve it. So there are two solutions, x equals to 2 and x equals negative 2. So my domain now, x cannot be positive or negative 2. Can't use either one of those numbers. So if you're looking at the number line, this is the minus 2, that's the plus 2. Any number but these 2 points. So from where to where? The first piece from negative infinity to negative 2. Add to it from where? Negative 2 to 2. Add to it from where? 2 to infinity. That's your domain. A lot of times we just write this, x does not equal to plus or minus 2. That means any number but these 2 numbers. And the range, now we have to graph it. And you got to pick a lot of points to graph this. Maybe. Wait a minute. That's an even function, it's symmetric. When you replace x with negative x, does it change? That's why we study symmetry. I don't want to pick 10,000 points to graph it. I know that function is even, is symmetric. How do you know it's symmetric with respect to the y-axis, or even function, that means symmetric with respect to the y-axis? You replace x with negative x. If it doesn't change, your function is symmetric with respect to the y-axis. If I do that here, my function will not change. When you take the negative x and you square it, still what? X squared. So that's an even function. So when I graph that, I only have to graph one side of it. When I pick values for x, otherwise you got to pick about 10 values. I go, well, I'll try the 0. I'll try the 1. I can't use the 2. I'll try the 3, the 4, and the 5. I might need a couple more points, but we'll see. When x is 0, that's 3 over negative 4. That's negative 3 over 4. When x is 1, what do we have when x is 1? That's 3 over negative 3, right? Which is negative 1. When x is 3, the bottom is 9. 9 minus 4 is what? 5? 3 over 5. When x is 4. 16. 16 minus 4 is what? 12? 3 over 12, which is what? 1/4, is it? When x is 5. 25 minus 4 is what? 21? 3 over 21, 1/7.
I'll push it up a little bit for us.
When I was trying to get the whole paper, that was the reason I was trying to avoid the whole paper. I hate having the black rim on the outside. The 2 actually, it's called vertical asymptote. You can't cross that. The values, the function is undefined. That's a vertical asymptote. When x is 0, it's negative 3/4, somewhere here. When x is 1, it's negative 1. That tells me the function is dipping down. That means if I continue to graph, it's going to continue going like this. It's not going to change its mind, go back up there. When x is 3, that's 3 over 5, which is more than a half, right? Somewhere here. When x is 4 is 1/4. When x is 5, start to descend, so it looks like it's shrinking. Since my function is even, it's symmetric, that's not a vertical asymptote. So if you fold the paper along the y-axis, you'll have that piece and you'll have this piece. Looks like a bridge or an underpass down here. What is the range? Where's the y value? Well, I know it's greater than 0. See it above this line, and it's less than or equal to what? That number happens to be what? Negative 3/4? So the range now, from 0 all the way to infinity, you also need to add to it from negative 3 over 4 to where? Down, which is negative infinity, right? So obviously I gotta write the negative infinity first, because we write the smaller value first, the largest value second. From here to here, and from here to up. From negative infinity to negative 3 over 4, also add to it from 0 to infinity. That's the range of that function. One of the questions I had to graph, I think Jason asked the question, was x plus 2 squared. And I said, well, I know that shifted to the left by 2 units. So we're going to learn about these techniques. If you know the basic graph of a function, by making a minor adjustment, you know exactly what's going to happen there. Huh? Nico, go ahead. Any questions, by the way? Go ahead, ask them. I'm in no rush. Let's say we have a function, f of x. It's the original function. And let's graph this function any way you want to. I didn't even tell you what the function is, but let's assume the graph of that function, I don't know, pick some crazy graph. You know what? Let's make it f of x equals x squared. If you were to graph that, what is the graph going to look like? It's a parabola. It's going to look like this. Now, if I said to you, can you tell me what the graph of this one will look like, f of x? or this is y equals, or f of x. Let's say y equals f of x plus a number. An example, if I said to you, can you tell me what the graph of what x squared plus 4, since that's a positive number, what does that mean? You're going to shift the graph if c is positive, you're going to shift the graph upward. How many units? C units. In this example, how many units we're going to shift it up? 4 units. So the graph of this, since I know what the graph of that looks like, this one says you're only going to move it 4 units up. That's what the graph will look like. Shift the graph upward, move it upward. It's called vertical shift, actually. That's the correct term for it, vertical shift, by 4 units. What happens if this number is a negative? Yep. This is shift the graph downward, C units. So if I want to graph y equals x squared minus 3, I will take the original one. The original one was y equals x squared, right? This is the original one. And what I'm going to do with it is what? Shift it down how many units? 3 units. And that's what the graph will look like. So you take the original problem, move it down 3 units. Notice my plus and minus at the end of the function. Okay, stay with the same function. Let's stay with it. What about if we ask you to graph y equals f of x plus c? Notice the x plus c inside the parentheses. I'm talking about something like this. X plus 2 squared. That's the one we did early.
Just to the left.
Exactly. X is always backward. When this is, notice, with the right direction is always this, the right way. When it's plus, we know y is positive upward. When it's negative, you go down. X is always backward. When x is positive, you go to the left. This is shift to the left. C units to the left. Again, for this, we know what y equals x squared looks like. It looks like this. So this one's going to be shifted to the left 2 units. The graph will look like this. And what about if this value is negative? You want to take a guess at it? Shift which way?
Left.
Shift to the right C units. So again, if I want to graph y equals x minus 3 squared, I know what x squared looks like. It looks like this. Because that's a minus 3, I got to move it to the right. How many units? 3 units. And the graph will look like this. So if you know the basic function, you can figure any modification to that function. Now, couple more things. How about y equals, instead of f of x, negative f of x? That's known as reflection about the x-axis. What does that mean? If I said, can you tell me what is y equals negative x squared looks like? I said, yep. Since you have a minus sign in the front, the original function looked like this. That minus sign is going to reflect that along the x-axis, flip it over the x-axis. So the function will look what? Change direction like this. The next one is going to be silly actually for this example. What about if it was y equals f of, trying to keep these, f of negative x. For this example, you won't really see it. This is what? Reflection about what? The y-axis. So if you have this function, I said with this you won't see it. This piece is going to have reflection. Just look at the piece on the right side. It's going to have a reflection about the y-axis. That will give me a piece where? This one, right? And that piece that was here is going to give me a reflection on that side. That will give me this one. So it ends up being the same function. But if I picked a different one, if I said to you, let's try a different one, f of x equals the square root of x. We know what the graph looks like this. What is y equals f of negative x looks like? That's reflection about what? The y-axis? You flip that about the y-axis, what is the graph going to look like? It's going to look like this, because the original one looks like this. Flip it over the y-axis will be that way. And the last one, with all these shortcut, what is y equals negative f of negative x? Reflection about the origin. Again, with this one, it might be better if I use this function. I know f of x looks like, the square root looks like this. So what is y equals negative f of negative x? That really says reflection about the y-axis and the x-axis. Two of them. Both of them. Because notice, the minus sign in the front is reflection about what? The x-axis. And the minus sign on the inside, reflection about what? The y-axis. So you're doing both. So your graph will look like this. This is the original one. Doesn't matter which one you do first. Reflected along the y-axis. Along the y-axis will be this. Then reflect that along the x-axis. What is the graph going to look like? It's going to look like this. That little piece.
Can't see it.
So that's the graph. It doesn't matter which one you do first, because you could have done this around the x-axis first, then reflect it on the y-axis, you end up with that piece. That is the graph right here. The graph of this is only this little piece right there. That's the graph of it. The other piece is just to get you to that spot. So those are the shortcut that we use to graph a function. couple more things in that section, then we are done. Any questions on them? Let's talk about composite functions. Finding composites of functions. Let's take f of x and let's assume f of x equals 2x minus 3. And let's assume g sub x equals, I don't know, cosine x. Can you tell me the fog of x, f composite g of x? And can you tell me what the golf or g composite f of x? I call them fog and golf. You ever seen that notation before? No?
Yeah.
Yep.
That's where the g function is inside. F.
Correct. This is f of g sub x. That's what it means. And this is what? G of f of x. That's what that means. Let's find the answer to them. So this is f of, do we know what g sub x is? G sub x is what? Cosine x. So how do you find the f of cosine x? We go to the f function up there, and every time you see x, what are you going to replace it with? Cosine x. So it's going to be 2 times, replace x with cosine x, and there's the minus 3. What is g of f of x? What's f of x? 2x minus 3. It says go to the g function, which is this one, and every time you see x, replace it with what? 2x minus 3. That's going to be cosine 2x minus 3. Are they the same? No. Usually they don't equal to each other. The only time they equal to each other if what? Anyone? If one is the inverse of the other. The result will be the same. Will be actually x. That's how we test to see if they are the inverse of each other. They cancel each other out. And we talked about odd and even functions last class. Even functions symmetric with respect to what? To the y-axis. An odd function is symmetric with respect to what? The origin. So even is symmetric with respect to the y-axis. How do you know the function is symmetric with respect to the y-axis? You replace x with negative x. If you end up with the same expression, you have an even function. Odd function is symmetric with respect to what? To the origin. So a lot of times in some books they'll say to you, instead of replace x with negative x, they go f of x equals f of negative x. That's how they write that. Symmetric with respect to the origin, you replace x with negative x, and you replace y with negative y. If you end up with the same expression, that's an odd function. Or they'll say f of x equals minus f of negative x. That's another way of saying it. Or they might even rewrite that as f of negative x equals minus f of x. So that tells you your function is symmetric with respect to the origin, or an odd function. This tells you your function is an even function. It's the same thing. Some people use this notation, some people use this one, this or that. Same thing. And that's the end of section 1.3 in a quick recap.